We also have the tree-wattled bellbird. Okay, this bird is very remarkable because it sits on top of a tree and it sings. Okay, it trying to lure the female. Okay, and you can hear even from a half a mile, you can hear the call, which sounds like when you hit a bell like that. Okay, that's how it sounds, and that's why it's called bellbird. We have many species of insects. This is, for example, a blue morpho butterfly. Blue morpho butterflies are, very abundant, especially during the rainy season, where there is a lot of fermented fruit, okay, like fruit that falls from the trees. And some people say that these butterflies have a very interesting flight pattern. Okay, it's very random, very erratic, and some people say that it's because they're drunk from the fermentation of the fruits. Okay, this is another organism that we have. It's a sloth, two-toed sloth. Is very common in the upper parts of Costa Rica, and then we have four species of monkeys in the country. Some remarkable ecological interactions. One of the things that I said is that epiphytes. Remember the concept epiphytes? Epiphytes grow basically everywhere. We've counted like from 60 to 600, okay, individual plants growing in one tree, okay? So imagine the amount of vegetation that, we have in Monte Verde. That's why we have more than 3,000 species of plants just in our area. So basically, when those plants die, a lot of them, a lot of the decaying leaves, like not necessarily go to the forest floor. They stay there. And so they decompose on top of the trees. And so trees have learned how to use that organic matter that sits on top of them by shooting roots out of their branches and tap into the resources there. So this breaks the theory that plants have like roots underground and all of that. In Monte Verde we have a lot of exceptions. This is a bioluminescent fungus. This is something that is one of the most interesting and intriguing things that we see in the cloud forest. And it's basically the only way to find them is by going to the forest at night without flashlights, without light, okay? And so they glow like I don't know if you ever gone like diving or snorkeling in the ocean and you see bioluminescent creatures. Well, we also have bioluminescent organisms in the cloud forest, but we also have this glowing fungus. Nobody knows to this point exactly why or how they produce that bioluminescence. There are two theories. One theory is that is to indicate toxicity to its neighbors, and then the other theory is that it's like calling, like trying to withdraw the attention from certain vectors for the dispersion of spores. And we also have many, interesting relationships. Like, for example, this is a tarantula hawk wasp, like parasitizing tarantulas. I'm not going to go into the details of that, but essentially, the wasp uses the tarantula as food for the larvae. Okay, and so that's how it happens. But in the adult stage, the tarantulas are essentially, excellent pollinators. They feed from nectar on flowers. We also have very interesting trees, such as strangler figs. Strangler figs are trees that start their lives as epiphytes, okay, on top of another tree, and end up being normal standing trees in the forest, okay? The reason why they do that is because being an epiphyte is good, because it's like starting the life in full light, okay, where the light, is available 100% for making food. But then, they have to absorb the water nutrients from the vegetation, okay, from the vegetation that is, in the histosol, in the branches, and also mostly from the air. And so the nutrients are not so much available up in the trees. Where they're available is basically here in the forest floor, where most of the organic matter decomposes, okay? And so these trees have learned to start their lives as epiphytes and then become normal trees, okay? By growing roots like that basically wrap around the stem of the host tree, and then eventually the host tree suffers a lot of stress because it has like an umbrella growing on it, okay? And so essentially they have a lot of stress because they cannot produce more photosynthesis, and because they are being squeezed, okay? And so the tree, the host tree, eventually dies and is decomposed completely, and it leaves the core of the strangler fig empty in the middle. So this is a picture taken from underneath the tree, looking up like that, okay? And so you can see that it's completely hollow. So it's one of a very, very remarkable trees. Some of the importance that we have, and almost, to finish and to wrap up this presentation, that we have in this cloud forest is that some people call or say that the cloud forests are like sponges of water, okay? The sponges to retain water. And so there have been measurements that have shown that the cloud forest provides up to 22% of the water that is available in a watershed, okay? So imagine like if we remove that vegetation. Another importance is for controlling the soil, like for maintaining, one of the things that I said before is that the soils are very fragile, very dynamic. And so having vegetation, like holding on to the soil, especially on top of mountain ranges, is very important. That's another reason why it's key to protect the cloud forest. And another reason why it's important to protect it is because, a lot of carbon is sequestered, a lot of carbon is fixed in this forest, okay? We have estimated that each tree in a tropical cloud forest sequesters 1 metric ton of CO2 in 25 years, okay? In Costa Rica, for example, our footprint, like per capita, is 1.5 tons of CO2 in 1 year, okay? Does anybody know how much is in the United States or in the world? Well, that's homework, okay? So Mary and Terry and everybody else, like, that's homework for your students. Also, protecting the biodiversity that exists there is very important because we don't know what nutrients are stored in this plant or what compounds are available there could be useful for us, for medicine, for products, etc. And another big importance for protecting this forest is ecotourism, okay? But as I said, if it is done sustainably, it could be a very powerful tool for development, okay? But if it's not, if it is done like not carefully without looking into how fragile the ecosystems are, it could be, a disaster at the end. Some challenges that we're facing in the cloud forest is global warming. Here is my friend, the extinct golden toad again. Global warming is generating, the increase in the average temperature, okay? In Monte Verde, the temperature has gone or has increased 1.5 Celsius, okay? And so that's equivalent of reducing the elevation, okay, of a mountain range in the tropics for about 300 meters, okay? So it's like saying before the mountain was 1 mile, okay, 1.6 kilometers. And now the elevation is 1.3, okay? Being in a lower elevation means that it's hotter, okay? And so that is ideal for new disease vectors, okay, to penetrate. And so that's one of the reasons why amphibians such as the golden toad and the harlequin frog, which are endemic to Monte Verde, have disappeared, along with 12 other species. Another challenge that we have is habitat loss and fragmentation. This is Monte Verde cloud forest up here. This is where I work at the University of Georgia Field campus, and this is my house over there. That's my little house, and that's my little ranch. And this is the cloud forest of Monte Verde. You can see how fragmented it is here. One of the things that we have done is like measure the impact or the effects of having this fragmented habitat on the Pacific slope. And one of the results of that, research has demonstrated that the ecology of this forest is fully dependent to the ecology of all of the other forests, like down the hill, okay? And so we need to connect this habitat. We need to connect this forest, not necessarily like, extend the park all the way down, to the coast or to the ocean, but like increase habitat, increase forested areas so that species or wildlife can migrate up and down, and so that we humans can also learn, okay, how to use this ecosystem in a better way, so that it's more in balance, let's say, with ourselves and with the species that inhabit. Another challenge that we have, as I mentioned, tourism. This is an example of like not really good tourism projects in our area that are more like, business as usual as opposed to like sustainable small scale. But for each challenge, there's always an opportunity. And here's something that we're trying to do in our country and in our area, which is the establishment of biological corridors. We live here in Monte Verde. This is the protected area. And all of these dotted or line polygons that you see all over the country are the national parks that we have. The green polygons that you see there, as you can tell, are trying to connect all of the protected areas, already protected in the country by the establishment of biological corridor. Basically, a biological corridor is an area, a geographic area, where there is enough habitat for species, for native species to survive and do all of their ecological jobs, and for humans to inhabit that ecosystem and benefit, from all of the services that are produced by having, a healthy ecosystem, a healthy environment. This is close-up, a zoom-in of the bellbird biological corridor. Remember the bellbird, the three-wattle bellbird? So that's our flag species. And this is, the dark green here represents basically the forested areas. And so the challenge that we have is connecting, these patches of forest all over here with this big patch of forest here and with the mangrove forest that is here in the coast of, here in the Gulf of Nicoya. So one of the things that we're doing in order to connect, to increase this habitat is mitigating the carbon emissions, that we produce by sending students from the US down to Costa Rica and traveling and then back to the US, For each student that goes from the US to Costa Rica emits at least 1 ton of carbon, just for the simple fact of visiting the country. So that's almost the per capita rate, amount for Costa Ricans. And so one of the things that we have is that we have tree nurseries, in the upper part of the corridor, where we propagate trees in order to offset the emissions, from all of the student programs that go to visit our campus, So if you participate in one of our programs, you have the guarantee that, if you purchase the certificate, it is going to be a carbon neutral trip, a carbon neutral academic program. Some other opportunities that we have is research. We have a lot of opportunities for developing, research programs, and we have already been talking with professors here at TCC who want to go and establish programs down there, and also education. You guys now, after seeing this presentation, you have, you cannot say no. It's like when you take a first aid course, and if you see, somebody in trouble, you cannot deny help, Right now, you guys, we're more than 100 people in this room, and our mission, is to educate others, Educate our friends, our families about, all these global issues that I have been talking about, conservation, connections, relationships. Like right now, we live in a very globalized world, and sharing this type of information with our neighbors, with our friends, with our family is very important because, we're seeing a very rapid change in how the ecosystems react to what we're doing, to our planet. And, one of the ways of how we have the opportunity, to reduce the impact that we are creating in our planet is by, seeing what we're doing, first, and then communicating others what other organizations such as TCC and UGA are doing. So I invite you to come to Costa Rica. This is what I do when I'm stressed out. I just go ziplining in the forest, and so I invite you to come. And I understand that next year we're putting together an excellent, itinerary for TCC group, tropical biology, and I welcome any questions or comments. Thank you very much.